Okay, everyone, thanks for coming to our October meetup after the first meetup after our conference last month. For those who are waiting for my conference recording, sorry, there will be a bit delay, but I will probably upload the conference video together with this recording of today's meetup this week. Okay, so first of all, thank you for signing up because I think this is the second largest number of sign up that we have for this year, 90 over plus. Although the real number doesn't reflect the situation. Okay. So today our topic will be more on F#, which will be delivered by first speaker HaiBin and the speaker outside. We will talk about .NET standards. So before they start, I would like to make some small announcement. First is that for those who are interested, would like to know where do our YouTube videos or uploaded is on our website .net.sg. Then you scroll to bottom, then you will see the subscribe now button. Please subscribe to our channel so that you get the notification when there's a new recording being uploaded. So all the recordings will be available here. And finally, I would like to also invite special guest today from the industry to have a short sharing about his company and his dream with you all. Okay, so now I should hand over to Taka from Hakovo.
That's okay. Good afternoon. My name is Taka from Japan. I've been based more than 15 years now in Singapore. So I'd like to introduce the Hakovo, but before my objective is here today to looking for potential future IT developer or CTO. That's why we are here. I'm here. And also now we're doing the Series A funding round. Then after we finish the rounding round, we immediately hire developer and also CTO as well. So that's why we are here. Chun Lin is a good friend with me, so asked me to, hey, why don't you come here to present, to talk about Hakovo, who is interested, also to us, let you know. So we still keep in touch. We also go to Chun Lin, then after that, I like to discuss more what your expertise and also what we can do together for potential for Hakovo. So maybe go to very quickly what is the Hakovo product. This is a digitalizing ocean freight shipping, like Trivago or Expedia for ocean freight. Ocean freight is like a container box. So customer, maybe small medium enterprise looking for the space or maybe box or maybe shipping from Singapore to maybe China or China to Russia. So we are matching on our marketplace, inviting the freight shipping company or logistics company. So who wants to provide the space or trading or something. This kind of the matching platform. Also, we are doing the executing the freight forwarding company, freight forwarding services. So maybe go to quickly. So this is the talk about me, model. Actually, prior to Hakovo, I joined the DHL, this is the logistics company. I was consulting, the background. Also, I do the learn the Kobo, this is what I bachelor in Japan. No one does now using. But this is my background in information science. Okay, Hakovo. This is actually two things I got the award from he is Minister of Finance. Just last week we got announced about it. Okay. So in the market, the forwarding market, actually you can see the market. Global trade management, electric, the communication, and also the trade digitalizing forwarding company. This is all we can see the competition. So marketplace, we are also marketplace like I mentioned, the Trivago or maybe the Expedia. Hotel suppliers coming, and also the airfreight suppliers coming, and also customers looking for the hotel. This is the marketplace. Forwarding company, forwarders like DHL cargo to send to the pickup and the delivery using the data solution. So there are no bundle services, but we can do it to provide bundle services to target customers to control end-to-end services, provide the trade compliance. In compliance, this is the customs clearance. We use in the data based on the customs clearance, financial inspector. So this is the kind of the data also create marketplace, plus combine the quality function. So we are start to getting the profit since the February this year, and also we are seeing going to expand the Indonesian market from the end of this month, end of next month, so end of this year, then followed by Japan and China setting up the entity. But we need more traction, also the investment from the venture capital. So now we are doing, as I mentioned, the Series A round. Once we finish it, we need more concrete services. We are doing some of the product is still beta version or prototype. So we need to come back to the final complete version. So that's why we need to develop that. Also, this is in every year or maybe every month, they change a lot of trends for the technology. So that's why the people who are very keen to know the trend of the technology, and also together with us, or to think about what is the trend. So maybe not necessarily to use the current one, but what is the best option for the technology to fit this industry? Like using the AI. AI definitely we need to deploy for compliance. This is also we are already figured out. That's why kind of the discussion what we are more glad to discuss. This is required one of the requirements for the CPA. So we are still preparing the hiring, the job scope. So maybe we still keep in touch. So after that, once we finish the funding round, then we also talk to them to open the discussion. Well, we can build a company for Goh. So actually, this is invested by PSA. PSA is a former forum of Singapore authority. Also invested also by Singapore, Enterprise Singapore, and then also we are connecting the Singapore government system. So we are like a kind of the project. That's why maybe we can see dream, but start from Singapore to go to the overseas. We are not only the trade agent, we trade the global, but kind of the global, the vision, So we really no more than 5 minutes I can introduce, but this is a Hakovo, so maybe I can come back to you later. Give him my contact, then also we can start to discuss. Then still keep in touch, but still maybe 2 or 3 months are required for us to finish it in the field. Sorry, just one shot, kind of. This is a place in the APL shipping company can see the customer center. Then do cooking, watching, kind of. Okay, thank you.
Thank you, Taka. So yeah, without further ado, so if you all have any shout out for your company or team or any interesting project, please always feel free to look for me. And Taka, will you still be here later? Yeah. Okay. So if you are anyone interested in his team, feel free to talk to him after our event. And now we have HaiBin to continue our first topic today, F-Shop.
Which one is the
HTML one?
Is HTML one? Okay. Good evening, everyone. So today I'll be giving you an introduction to F#, basics to functional programming. So this mouse is not working. Okay. So this talk is for beginners only. So if you already know what a monad is, or if you have some basic introduction to functional programming before, you may find this talk a little bit easy, but bear with me. So about me, I graduated with degrees in mathematics, like for my bachelor's and master's, so I really like functional programming, which explains why I like functional programming. I'm currently working as a financial engineer at Numerical Technologies. And what is functional programming? I try to distill down like the most core concept of functional programming. It is based on combinatorial logic, and you use functions to solve problems. Of course, there are other good properties of functional programming like purity, type check, etc. But I want to focus on the function part, just for this talk today. And some of the functional languages, like some of the ancestors are like ML or Haskell, but it has a lot of descendants and cousins, which today I'll be focusing on F# because it's on the .NET. Some people also say that libs and some of their dialects are also functional languages, but I'll put it aside for now. So who uses functional programming? So for example, Standard Chartered uses Haskell, Walmart and Jet, they use Clojure. Jane Street is a big trading firm, they use OCaml, and LinkedIn and Twitter, they use Scala. But I'm not so sure how big is that Scala right now. So just to let you know that there are a lot of companies out there that uses functional programming. And why learn functional programming? Because you can write your code very concisely. You are able to write more stuff with less words. So you're able to write things concisely, and you are able to reason about your code. And with a better vocabulary, it helps you unlock more difficult programming problems. And worst comes to worst, there's always better salary, because it's a little bit hard to find functional programmers out there. And if you have any questions, feel free to just raise your hand. I'll answer your question. So this talk will be focusing on F#, but there are Scala, Haskell, Clojure, and Elm meetups all like in Singapore. So if you're interested in any of these other functional languages, feel free to go and check them out. So if you're using, I'm assuming that most of you use C#, right? So if you're using C#, should you be using F#? If you're eager to learn, then of course, yes. Because it's fun, it's easy to learn. And once you learn F#, you're able to access the other functional languages like Haskell or maybe Scala and other stuff. It's easy to transition from one functional language to another. And it helps you to change the way you think and how you do program. And also you can directly call F# directly from C#, which is a huge plus. If you're already programming in C#, it's like a more tool set for you. If you are skeptical, I would still say yes, it's worthwhile to learn F# because a lot of new features in C# does come from F#. And F# has a better syntax for you to learn these new concepts that C# is slowly adapting. So eventually you'll learn functional programming like one way or another. So why not just start with F#? Okay. So the core concept of functional programming, at least I try to distill down the two, is functions are things. The analogy I would like to use is like a coffee machine. I'll explain the analogy later. And you can compose functions. The analogy is this toy train with the wooden track underneath the train. So here are the two analogies. Functions are things, and you can compose functions. So what is a function? A function can be think of as a machine that takes an input and returns an output. It takes an input and returns an output. So let's look at an example. So a coffee machine takes coffee beans and returns coffee the drink. So the coffee machine takes an input, returns an output. And some mathematical functions. Let's say that f is a machine that takes a number x and returns x plus 5. So if you throw in the number 10, it gives you 50. So far so good, right? If I throw in 20, it gives me 25. So in F# you will write something like this. This is actual F# code. Let fx equals to x plus 5. This thing compiles in F#. And then to call the function, you just write f30, which will give you 35, f100 gives you 105. A slight difference, you don't need brackets. A little bit different from like mathematics or in C# notation, you don't need the bracket. In math, you write something like that. In F# you don't need the brackets. So far so good? Then to use the function, again, you don't need the brackets. In mathematics or maybe in C#, you need the brackets to call the function, but in F#, you don't need it. So example, so let fx equals to x attached with a hello in front of it. So I take a string x and then I attach hello in front of any input. The diagram would look like this. Easy enough. Let's try another example. Let's say that I take a string x and I return how long is the string. So for example, hello gives me 5, computer gives me 8. So the diagram will probably look like this. Let's look at another example. So let xs be a list of numbers and I sum them up. So I take a list of integers and I return a sum, the integer. The diagram would look like this. I take in a list of stuff and I return one output, which is a sum, a number. So if you have multiple inputs, then I will write like fxy equals to x plus y, where I have two inputs, x and y, both are integers, and I return an integer. Notice a slight difference that you don't need brackets, you do not need commas. In C# you probably need commas or like brackets, but in F# you don't need it. So in math you'll probably write something like that, but in F# you'll write like that without the brackets and without the commas.
What's the different thing?
What's the different thing?
The first thing you write in Cartesian product.
Yes.
And the second time you have a function that produces a function.
Technically, yes. I'll get to that later, yes.
I mean, the first thing is valid syntax in the
Yes. Yes, technically speaking, the first one is a valid syntax in F#, but it gives you something completely different. But I want to ignore that. Because in mathematics, at least I would write something like that. But I just want to, just like you said, I just want to get rid of all the brackets and commas because I want to avoid the condition problem. And then to use it, you don't need to use the bracket, don't need to use the comma. And if you have multiple inputs, you write fxyz equals to something like that. And if you have multiple inputs, let's say a, b, c, d, then you write something like that. Where if you look at the type signature, like this function takes in a, b, c, d, and returns an output. So far so good. And function composition. Two functions can be connected together if the output of the first function is the input to the second function. Here I want to draw the analogy to the toy train tracks, where you can connect the train tracks together if like the first one fits to the second one. So let's take a look at this. You have a machine that takes an apple, returns a banana. You have a second machine, takes a banana, returns a strawberry. And the first output is the second input. And so you can put them closer together, and then you can put them even closer together, and it is effectively a bigger machine. You combine the two machines together, and it gives you a bigger machine. Effectively, the banana is hidden. You don't need to know what's going on in the middle. You can say that it's composed of little tiny functions, and you get an even bigger function. So if you have a coffee machine that produces coffee bean and produce coffee, and then you have a programmer that takes coffee and then produce software code, these two can be combined together, and effectively we have a bigger machine that takes coffee bean and returns software code. You don't need to know what's going on in the middle, like there may be some coffee machine in there, there may be some sad programmer in there, but it's a bigger machine that takes coffee bean and returns software code. So if you have a machine F and G, and A to B, GB to C, you can connect them together. You can write GFA. You can write something like this, which effectively will evaluate to C. So let's take a look at an example. Let F, I take a list of integers and I sum them, I add them up. And based on the final score, I determine this student whether he gets an A or B or C in his class, his or her class. So these two functions can be connected together, and so like the diagram looks like this. I take a list of numbers, I take a list of exam scores, I add them up, and I determine the score. These two functions can be connected, and so I can write maybe something like this, and it connects well. Of course, the type must match. If the type doesn't match, like the output of F cannot be connected to the input of G, then there's a compile error if you write a statement like that. You cannot connect the functions together if the type doesn't match.
So that's not usually you can follow all this bracket. But one,
Yeah, this one I purposely put the bracket to show you the conventional way of like doing composition.
before the slide.
For the slide, this one.
Yeah. So you still put bracket.
The square bracket is for the list of numbers. It's for the list. The curly bracket is there to use the function. I just want to make things a tiny bit clearer. But yes.
So square bracket parenthesis here is because F sharp is left associated. So if you write G of F without square bracket, it will try to apply G to F and then apply second function to result of like what you get of this G to F application. Here we can break this rule, and we first have to evaluate what's within bracket.
Just want to say you can ignore the bracket.
No, you cannot. It will change the semantic because
For this you can't ignore the bracket.
In this one, there's three things: G,
Yeah.
F, and the list of numbers.
Yeah.
If you remove the bracket, it is as if you're applying G that needs two things. It's completely different meaning, yes.
Okay.
Yeah. And so I want to get to the most important thing in F sharp is the pipe forward operator. This symbol, a vertical line with like a angle. This is a very important operator, the pipe forward operator, a key idea in F sharp. Why is this operator important? This operator allows you to change the order of the function and the input. This allows you to change the order of the function and the input. So let's take a look at an example. Fx equal to x plus 5. To use the function, you normally write f of 100. You tell me what's the function, then you tell me what's the input. Now instead, you can say 100 pipe forward into this function f. You tell me what is your input and where do you want to apply it to. So it allows you to change the order. How is this useful? Is that if let's say you have two functions that can be connected together, you can write conventionally GFA, like with the bracket, or you can completely write it in reverse like this. A pipe to F, pipe to G. Usually, we prefer to write it in multi-lines, like this. We write it in multiple lines. And the reason of writing like this is that the angle, that symbol can be interpreted as a then do. You can interpret it as a then do. You start with A, then you do F, then you do G. Why is this helpful? Is that you start with X, you pipe it to F, you pipe it to G. You can interpret it as you start with X, you apply to F, you apply the result from F to G. You can apply it like this. And maybe you are not satisfied. Maybe like the toy train track, you want to connect more tracks, you want the train to go further, you want to connect more tracks, I add one more statement. That I'm not yet done. I apply what the previous result to H. Maybe I'm not yet done. I go one more step. All of these, like the code on top will compile and it will be interpreted like that. You can connect and connect and connect. You can go as far as possible. Just connect and connect. That's the analogy. As long as the first output is the second input, the second output is the third input, etc. As long as the condition holds, then you can connect and connect as much as you can. In C#, you can probably write something like this if you define the then operator. It is a little bit not so natural to C#, but you can definitely do it. A little bit not so natural, but you can do it in C#. So the benefit is that you can express your logic step by step. It's like step 1, step 2, step 3. It's quite logical, and it's easier to read for the lay, like the normal people. So I'm going to try some Project Euler questions. Have you guys heard of this Project Euler website? Yes. It's some programming website with a bunch of like math programming problems. So I'm going to try some problem from this website. So, question 1, find the sum of all multiples of 3 or multiples of 5 from 1 to 999. How would I solve this problem in F#? I would do something like this. I'll give you like maybe 10 or 20 seconds to take a look at it. and then I'll show you the interpretation. The interpretation would be like this. You can see a line-by-line comparison from 1 to 999. Then you do some filtering, like a water filter. You filter so that you keep the things you want, which is multiple of 3, multiple of 5. You keep the things you want. Then you sum up the remaining numbers that you have kept. So you can see a line-by-line comparison. Of course, you can already do this in C#. That's link queue. You can already do this in C#. It's link queue. But effectively, it's the same thing. Let's take a look at another. So is this okay?
Good question. Fun is.
Fun is mid function.
Is it the name or is it?
Fun is a keyword that represents a function, like a lambda expression. It's a function that takes x and return x divided by 3 is equal to 0, etc. Fun is a keyword. Is this okay? The percentage means x divided by 3 gives you a remainder of 0, which means x is divisible by 3. Any question? Yeah. So, the diagram would look like this. You start off with the first list. You go through the first machine so that you have the middle step that contains like the remaining numbers. And then you go through a second machine that sums up everything. That's where the connecting comes in. Any question? Okay. So let's take a look at the question 6, a little bit modified. Calculate 1 square plus 2 square until 100 square. The code would look like this in F#. The English interpretation would look like this. From 1 to 100, you individually square each number, and then you sum up. Of course, you can already do this in C# link queue. It is the select. And the diagram would look like this. You start off with the first list, you individually convert each element, and then you sum them up. Like the converting part and the summing up is like two different functions. Any questions? So if let's say I want to sum up these squares of prime numbers, then maybe I'll do something like this. From 1 to 100, I take out the prime numbers, like the second line, I take out the prime numbers, I filter out the prime numbers, then I square each individual prime numbers, which is the third step, and then I sum them up. Of course, I need to self-define the is prime function, but you can certainly, once you define it, it's very simple, like 4 lines, like step 1, step 2, step 3, step 4. You can almost translate it like line by line into English. Any question?
Sorry. Why? So this filter looks weird.
This
So
filter.
Yeah. It can
Oh
be
yeah.
List filter is prime is enough, and fun x to is prime of x is just noise.
Yeah.
Maybe we should just let them do the presentation because I think this is for beginners and I think it's probably if we skip array and if we skip point implementation, I think it will be easier for the beginners maybe to understand it. Just
Yeah, but you started with a function being like first class citizens, and this is a perfect example where you can show that like function itself can be passed around. You don't need to construct this lambda. You can use is prime for filtering.
yeah, but then he has to explain point implementation, which is going to be a little bit harder for beginners.
I'll be able to get to the point relocation, like something similar maybe at the end of the talk. Thanks for the suggestion. Thanks for the suggestion. Thank you. So an example. So like, if let's say you have, because I'm working like in probability theory. So let's say you have 3 events occurring with a probability of 0.2, 0.3, and 0.4. The probability of no event happening, which all 3 events not happening, would be that 1 minus 0.2, 1 minus 0.3, 1 minus 0.4. And so the probability of at least one event happening will be 1 minus the previous result. So this is like a very basic like math or statistic calculation. In general, if let's say you have P1, P2 until Pn, you have like a list of numbers, then that's the probability of no event happening, that's the probability of one event happening, like the same formula. We have a list of numbers. How do you write down a calculation that calculates this? In F#, I'll probably write something like this. You start with a list of numbers. You convert each number to 1 minus Pn, 1 minus Pi. Then I calculate the product. I just multiply all of them together. And then I do 1 minus the final result. Of course, I need to define list of product, but I can do it. And then that will be something that I'll do in F#. You can do something similar in C# as well. Something like this. You use link queue. You need to self-define the product. You need to self-define the den. But you are able to define like one number like in one go instead of like breaking into intermediate steps or something like that. Is everything okay, Zuma? Okay. And now I'm going to talk about partial application, and which is a very useful language design. So if let's say I have a function that takes 4 numbers and I add them up. So right now I apply all for 1, 2, 3, 4. I expect the result to be 10. What if I forgot one variable? This thing has 4 inputs, but I only provided with 3 inputs. Will this compile? Yeah, it does. And it does compile, and it gives you an integer to integer. So the analogy is this: if you have a machine or a function that needs 5 inputs, you only provide it with 2, then it still needs 3 additional inputs. Put it in another way: if you have you need 5 inputs for a function, you only provide it with 2. We are producing a brand new machine, a brand new function that still needs 3 inputs. So if I write f of u, v, w, x, y, but I only provide with a u, v, then I produce something that still needs 3 inputs. In C#, if you write something like this, it will fail. Like it will have a compile error.
So it's in F#, you still take the compile. There's no error.
For this specific case, it has no error because I provided with 2 inputs. It still needs 3 inputs, so this result thing still needs 3 inputs. It is a function.
Could it be FU, W?
No, cannot, because I expect the second one to be V. If you give me W first before V, it will have a compile error. So for example, in C#, I need 2 inputs, but I only provide with 1, then there's a compile error. So example, let's say that I have like some data points, and I want to find the linear interpolation, which means if I give you an x0, I draw a line vertical on top, and I hit like one of the straight lines, and I calculate what is y. So this is a process that depends on the x0 point, and it also depends on the data point, this blue colored data point. If I provide it with a different set of data point, for example, this yellow point, it gives me a completely different y0, even though my x0 is the same. So this is a function that depends on the data set provided and the x0 provided. If I provide only the data set but without x0, so for example, let's say I have data set 1, data set 2. I provide it into the interpolation function. Now I have f and g. This f and g still needs x0. The interpolation needs 2 things, but I only provided the data set. So this f and g, both of them, takes x0 and returns a y0. But the tricky thing is that the y0 provided, like there's a hidden dependency that depends on the data set that is already baked into the function f and g. So that's how. So effectively, you can use f and g in some of your future functions, etc., etc. But there are some hidden dependency that's baked into f and g, and it makes things easier to write once you have partial application. And some say that partial application is sort of the equivalent of dependency injection in C#. Like some people tend to say that. won't elaborate more. So the special case that if you have n, if your function needs n input, but you only provide it with n minus 1, then you still need one more input. So effectively, you produce a one input, one output function. If you have n and you provide n minus 1, you still need the last input. The diagram looks like this. You need a, b, c, and x into a function, and you produce a y. If I put in the inputs a, b, c right here, I put in the a, b, c right here to my input, and then I squint my eyes a little bit, I make the picture a little bit blurrier. Effectively, it looks like this. Effectively, I block out all the holes, and it is an x to y function. Why is this useful? Is that I assemble everything. Let's say that I have a function like that on the top, and I provide it with almost everything except the last input. So effectively, it is an x to y function. Maybe I have a second function like that after I provide with everything except the last input, it is a y to z function. So now I can connect them together. It's x to y, y to z. I can connect them together. So notice that each of these is that I assemble almost everything except the final component, so that I can start connecting them together. So here are some of the example codes that I showed you just now. Notice that this involves assemble almost everything. Like inside there, I have a filter function and another function inside it. That thing is like I assemble everything so that I can connect them together. I assemble almost everything and I can connect them together. And this special case, you can already do it in C#. It's called the C# extension method. It's the this keyword in C#. So if let's say I have the function fgh, where part of the output of f is part of the input of g, the output of g is the part of input of h, then using the this keyword, I can connect them together in C# something like this. So you can use the C# this extension keyword to do this kind of like piping operation, like you connect and you connect. And effectively when you compile it out, it looks a little bit ugly. It's a very good syntactic sugar for you to do the connecting in C#. It's a good syntactic sugar. And more importantly, the general case is just for fun. So just now I mentioned that if you have a function that takes in 4 inputs and return 1 output, in C#, if you try to partially apply this, all of these will have a compile error. It will fail. In C#, this will fail. In F#, it will not. So that's the type signature function ABCDZ. The second one, the function ABCDZ, is not flexible because you need to assemble everything before you can start calling this function. So this is not really a flexible signature, like type signature. The first type signature is more flexible. Why is that flexible? Is that this signature, if you provide it with A, I still get the red stuff. I provide it with A, I still get the red stuff. I provide it with AB, I still get the orange stuff. I provide it with ABC, I get the white stuff right there. So this type signature is more flexible because you can partially apply. You can just give me part of the thing. You don't need to give me every single input, and it will still compile. So with some helper function, which is the currying function, you can write this helper function in C#, and then you can take your original function f, and then you can convert it into a special version of this function f, which I call it g, and now GA, GAB, GABC, all of these compiles. I mean, whether this is very useful to your source code or not could be questionable, but I think this is kind of fun-ish. You take a function f that you need to assemble everything. Now I can just assemble part of it and it compiles. It's kind of fun, I guess. Any questions? And now let me get to higher order functions, which is functions as inputs. So the typical functions that we write, usually at least on a lower level, we'll take in primitive types like double, integer, strings. We take in these very basic inputs. but you can start taking functions itself as inputs. You can have a function that takes in another function. You can also have a function that returns another function. The analogy would be like this. Take a look at the left-hand side. The left-hand side is a coffee machine. The coffee machine itself is a machine, is a function. The coffee machine itself is a machine, is a function, but it gets accepted into an even larger machine, an even larger function. In this case, it is the coffee shop. So the coffee shop is a larger machine, a larger function, that takes in a smaller machine, a smaller function, the coffee machine, to produce coffee. So let's take a look at like some of the examples right here. Just now we did like filtering and map, where we filter out the stuff, we convert each individual element. So the filter function, I have a list of X, and I want to determine whether I want to keep it or I want to remove some stuff. How do I remove, how do I keep stuff? I need a function that gives me true or false. I need like a detector function, like X to Boolean, the X to Boolean function right there. So the filtering function, the C# linkQ.where, the linkQ.where itself is a bigger machine that takes a smaller machine. And then the F# map, which is the linkQ_select. This linkQ_select, I have a list of X. I want to convert it to a list of Y. I want to know how to convert each individual element from X to Y. So that thing itself, I need a function that goes from X to Y so that I can know how to convert each individual element. This map, or the C# linkQ.select, this itself is a higher order function that takes another function as an input. Is everything okay? Any question? So let's take a look at the example. Let's say that I'm developing some like insurance product. I want to determine how much I want to charge a customer. So I have a price. Maybe this product depends on integer, like depends on age. Like maybe if I'm getting younger or older, like the price of the insurance product should change. So maybe this function takes in an integer and returns an amount, like $1. Maybe this depends on the probability of injury. Maybe I'm 5% likely to get into a car accident this year. Who knows? So maybe this number should affect like the price of this insurance product. But what if this probability depends on time? So maybe I'm 5% more likely to get into a car injury this year. Maybe I'm 10% likely to get into a car injury next year. So this probability of injury depends on time. So it's like not a constant, it's changing. So you can give it a function. So this pricing algorithm like takes in an age and takes in a probability function. Then depends on which day is it, which time is it, and it gives me a double. So this price function takes in another function as an input. Is this okay? So let's take a look at another example. So Newton's method. So you have some function that you want to find the root of this function to. So I have this function, I want to find where is it 0. So this algorithm, this Newton function algorithm, depends on the starting point, which is a floating point, a number, and it depends on a function, depends on f, it depends on the function that you want to solve, and it also depends on the derivative of that function, df. So this Newton method, this Newton function, this Newton algorithm depends on the starting value, and it also depends on a function, and also depends on another function. Technically speaking, the derivative depends on the original function. But anyway, this function, Newton function, itself takes in another function. So this is just like some basic application of functions taking a function. So that's like some of the most basic tricks in F#. Then you should try to chain or connect your computation as much as possible. You connect the train track, you connect the train track, you connect the train track, so you can do a lot of computations in one go. You can also use partial application to get a new function, which in C# you can use this keyword, like the n-1 trick. You can already do this in C#, this. And also you can do higher order function, which means that you can use functions as input and out as inputs to your functions or as output to your functions. Of course, there are a bunch of other properties, like good properties in F# that I don't have time to go through today. So some of the good learning resources that I know about F# is this fsharpforfunandprofit.com. This is a very good website for you to learn F#. I highly recommend it. And also F# also has an organization, fsharp.org. That is also a good website for you to like know how to install F#, how to get started. And there's also a good book by Thomas Patricia, Real World Functional Programming. And if you're looking for, let's say, other conference video, like, you know, to whet your appetite to get you, like, you know, started, I recommend, like, Scott Vlashin. He's a very good, like, tech educator. He has a lot of good talks on YouTube, on NBC. If you are interested, you can try to watch some of his talks on YouTube, and it should be pretty interesting. And if you want to get started, you know, there's an F# for Fun and Profit blog. Then you can try out some project order questions. I have some training materials that I use to train my interns. So, you know, if you're interested, you can ask me. And, you know, here are some sources that, you know, which companies have been. That's the end of my talk.
Can you share some real life experience from your work where it will be like very difficult or impossible to be done like in C#?
I know that most of like our statistical and mathematics calculation that we do, like we do most of those calculations like in F#. Of course, it's good for that, but one thing that I noticed about F#, like and also functional programming, is it's helpful for you to help you detect like some of the corner cases, in particular null values and missing values. Like once you get exposed to F#, you'll start to appreciate, you know, like dealing with null is quite kind of bad, dealing with exception is kind of bad depending on your, you know, like your opinion. Like I personally believe that exception is kind of bad, right? Gives you the concept of, you know, try to isolate, try to deal with things as soon as possible, which even though quite a number of our source code is in C#, but after going through F#, I started to notice like there's this thing wrong and that thing wrong in C#. Even if you don't get to use F# in your work, once you learn F#, you'll start to notice like things going wrong in your C# code base, and you'll try to adapt it a little bit towards like the F# stuff. I mean, of course, like mathematics and statistics calculation is always good in F#, but I want to stress that even non-mathematics or non-statistics calculation or, you know, code base could benefit from F#. Any other questions?
Does Microsoft have any plans for promoting F# or encouraging coding to use because right now it's a wonderful language but it's extremely unpopular. So it's kind of hard to find a new job.
I would say that, like, you know, in terms of F#, like most of the jobs are most likely in like either Europe or maybe like in New York City. Like some of those like finance company uses like F#. To be honest, if it like it's also like, you know, part of my regret. I kind of regret that there's not much like F# jobs out there. So probably in terms of more practical perspective, like, you know, like learning F# is more helpful to, one, like notice like some discrepancy in your C# code. Like you can start using like F# like functional programming techniques in your C# code, or you can call F# functions that, you know, would take forever to write in C# or like you make a lot of errors in C#. You'll call directly from F#. And the second thing is, you know, transit. It's a little bit bad that I'm saying. It's like Microsoft Office that, you know, once you learn F#, you are able to transition to other functional programming languages. You know, Standard Charter is a bit higher.
I guess then functional programming is still not as widespread as object-oriented. However, in terms of C# and F#, it's still cool to learn F# because the mix in C#. Yes. So I think in certain things like formulas and things, it's nicer to
skills, and then you'll be a much more rounded programmer. That once you hopefully employer should be able to see that with C# and F# experience is like a good plan.
So is that experience that you wish when you write C# code and you wrote the F# function, is this experience persons or there is some other people?
If you just isolate your code so that you only take in like IEnumerable, like sequence of function. You use IEnumerable, you try to use data structure that is compatible to both C# and F#, then the process will be smooth. So I started experimenting with C# and F#. I noticed that the list data structure is different in C# and F#. Like there are some slight differences that makes things a little bit complicated. So once you isolate your data structure to the common data structure that's used in C# and F#, in particular like IEnumerable, then the programming process should be smooth. So, yeah.
Thanks.
So before open to the second speaker, we will have a short hi I need to give to Jeff, who is late for our
Hey, you don't
meetup
tell
as
everyone
well.
I'm late.
So that's why actually I am supposed to have two speakers from industry today. So that's why
I'll just take out a short time. Right, I'm mainly here to do recruitment. Right, so just to shout out about my here we go. We are Telepathy Labs. What we do, we are founded in 2016. We are enterprise AI speech and data integration service. Right, so what we do is we help really huge enterprises, Fortune 500 types of companies, right, to integrate data and then retrieving data through speech. We have our own speech stack, right? So currently in stealth mode, we are well funded. We have 3 offices: US, Switzerland, and Singapore. Below a bit less than 100 people now, and we are still growing, right? So we have some quite renowned people. Nuance and those industry leaders are part of our company, right? Ex-Nuance. So if you are interested in working on cutting edge stuff, this is what we are doing. So we are currently hiring software engineers. Today is a .NET one, so I'll talk mostly about .NET, but we're also looking for C++, some Java, right? Next, right? So software engineer, database systems, we are looking for someone with in-depth knowledge of database systems, not just using database, but really know the inner workings of a database system, right? So like how to implement exit stuff and stuff like that, like building a database from scratch. We are not building a database from scratch, but these are the things we are looking for in candidate like that. So a mid-level or senior software engineer, right? So these are the requirements. I'm not going to go through in details. You can read. So and then we are also open to hiring junior, right, or fresh grads. So yep. If you are interested, you can email me your resume and just ping me on my email. So I'll flash this for a while. If you are interested, you can take it down. I will not be here for too long. I have a meeting later on, so I have to leave soon. So if anybody is interested to take a picture of this or something, right? So that's it. Thank you. Flash this for a while. There's a break, is it? No. Okay.
Then I will put your details on.
Okay. I can. Thanks. So thank you.
Thank you.
Okay, so I will be talking about the .NET ecosystem and .NET standard. First, I will introduce myself. I'm Rastislav Novotný, coming from Slovakia. Basically, software engineer for more than 15 years, almost 20, mostly on Microsoft technologies. I think it started even with Visual Basic, so it was a really long time ago. Currently mostly focused on DevOps and things like this. And you can find more information on the website, or you can follow me on Twitter or see on Meetup. Shortly about me. So what we will be talking about? Several things. I mean, at first about .NET ecosystem. It means like what platforms, what technologies are there, and so on. Actually, when I was at the .NET Singapore conference, I think there was a question like how many people use .NET Core. I was actually surprised that not that many. A lot of people still use the .NET framework. So I mean, what I will be talking also is about like how you can use some parts or some nice features of .NET Core even when you are still using .NET or developing a .NET framework, because I know like final production must be .NET framework on some Windows somewhere and so on. Yeah, and we will talk basically about common language infrastructure, about .NET standard itself, standard tooling, and as in the end, as I said, I mean about ASP.NET Core, but again, I mean focus mostly on the things that you can use on different platforms. So at first about .NET ecosystem. I'm not sure, maybe you've already seen this this poster. Actually, yeah, again, like on this year on .NET conference, I mean they started, or the main idea was that .NET runs on different platforms from, of course, desktop servers, mobiles, and now they added like IoT, machine learning, and things like this. On the other side, it was just very simple poster. Actually, like this one quite more. This is from previous year, from .NET Conference 2017, and it also basically shows that I mean you can develop on .NET yeah, for servers, for desktop, for mobile, IoT, and even games. I mean using Unity. Maybe some office development and so on. And actually last year they released .NET Standard 2.0. I think it was last, or it was this year. I think last year it was .NET Standard 1 point something. This year I think it was 2.0. And basically, I mean, this is the standard that somehow connects most of the platforms, and I will explain what is it and how it influences. So at first, I mean, let's talk about what is about different standard that is related to .NET, that is common language infrastructure. And this is actually, I think it's ISO and CMA standard. And that's basically it's standard that describes, I would say, .NET framework, like how it should operate or how it should work. So basically, what it describes is like what is the assembly, what is the content of the assembly, I mean the .NET assembly, what is the format, how the resources should be in, what is intermediate language, what instructions are there, what metadata type systems is, even it describes somehow like what is exception, how it should behave, the exception system, and so on, and things like this. So it is somehow the standard that describes the virtual machine or the runtime that you use, or that in the end describes the assembly, or that what you will type in C# you compile the assembly, and I mean that standard that output is described by this common language infrastructure. And then I mean this standard, I mean it has several implementation. The implementation is actually common language runtime. The common language runtime, and it is really the implementation basically implements the garbage collector, memory allocation, really the exception handling or exception throwing mechanisms, assembly loader, compilation to native code, and from intermediate language to native code language, and so on. And so, I mean, there are several, nowadays, like 3 main implementations. One is .NET Framework, that is the oldest one, then Mono and .NET Core. And I mean, they implement all the same standard, the common language infrastructure standard, just of course each implementation is different. Like for example, I mean, especially the assembly loader, for example, might be different. For example, in .NET Framework, the assembly loader can load assemblies from global assembly cache. Although Mono somehow implements global assembly cache, but for example, .NET Core does not have global assembly cache. And things like this. And I mean, according to the standard, I mean, there may be also in different implementations, and this is actually what makes .NET quite portable. That you have some standard, and again, you just need some implementation for specific platform, for example, even for mobile or whatever, and then it means you can run the assembly that you write in C# or compile from C#. And basically now let's talk about what is .NET standard. Yeah, let's start about evolution. Yeah, so I mean, quite some long time ago, I mean, Java started with the slogan that write once, run everywhere. Then few years ago, it was like JavaScript started to rule with the slogan like one language to rule them all. And actually, 2 years ago, .NET standard came with slogan one library to rule them all. And that's the difference. I mean, like JavaScript is more like that. It is the language, but I mean there is like millions of npm packages. With the .NET standard, they try to standardize one library that you can use on different platforms and don't need to switch from one package to another. And how it actually evolved really is that, I mean, Microsoft.NET started in 2002, and actually at that time, I mean, it was also released this common language infrastructure as a standard, and more or less at the same time started also Mono implementation. I mean, yeah, at that time, I mean, maybe the Microsoft and open source was not that friendly. But on the other side, I mean, at least like this .NET standard, common language infrastructure helped implementation of Mono. I mean, that they just implemented it according to the standard. And then, I mean, like several years later, I mean, started Silverlight, and I mean, several different platforms, I mean, or implementation of .NET. So Silverlight, it was Windows Phone, Universal Windows platform. And when started Silverlight, of course, I mean, people started to ask, okay, but if both are more or less .NET, how can I use or develop for both platforms? I mean, if I want just to write some library just once. So, I mean, therefore, Microsoft came up with a portable class library that I will soon explain what it is. That help, I mean, that you develop based on the portable class library, and then I mean this class library that can run on several platforms. And after, I mean, with the .NET Core, they switched from portable class library to .NET Standard. And I mean, again, the .NET Standard is also somehow the library that you can compile against. and then I mean this your application or library then can run on different platforms that actually support .NET Standard. I will explain actually how it works. Or it's very clear, I mean, what are the challenges? I mean, why we need something like portable class library and things like this. So I mean, as we have the common language infrastructure, and we have the same assembly format, same intermediate language, same simple types like objects and so on. So it means, I mean, if we basically compile from C# some assembly, I mean, it basically should run on all the platforms because, I mean, it has the same format. So I mean, yeah, this is true. So, for example, if I go slide back, I mean, for example, okay, if I compile if I build standard .NET library and I try to use it on Silverlight, actually, basically, I mean, Silverlight can still load it, can still somehow understand the content, understand the types, even the intermediate language. The problem is actually with the references. Because, I mean, like some of the types in different platforms are in different assemblies or and so on. Like, for example, if you take system GUI, then in .NET Framework, it's in MS Corely version 4.0. In Silverlight, it's also in MS Corely, but in different version, and in .NET Core is actually in completely different assembly. So, I mean, the problem with the multi-platform compilation or running is actually not the assembly itself, but I mean, it says, for example, you are using GUID in your library, in your application, and you try to load it. So of course, I mean, the runtime times, okay, you reference, let's say you compile it to against .NET Framework, that's 4.0, and you try to run in those Silverlight. So I mean, the library uses GUID. So okay, GUID should be in MS Corely 4.0, but Silverlight, okay, I don't have this library, I don't know where to load it. That's the whole problem. So I mean, we have the missing types, that's one of the problem, and also I mean, another problem is that some types are in different assemblies. And the third problem might be, I mean, it's somehow related to this too, that if I'm using like third-party library and it's, for example, compiled against .NET Framework, then how do I make sure that, I mean, it's not really used on, or that the third party is not really, or is referencing only, let's say, .NET Framework libraries, also it wants to write only Silverlight libraries. So how to share the code, and there are actually like 3 options. First one is shared code, and shared code is, I mean, quite simple. I mean, you just type the same code and just compile it using C# compiler against different, I mean, referencing different libraries. So for example, you have the same C# code, and for example, for .NET Framework 4.5, you need to reference MS Corely, systemdll, and so on. For .NET Core, you reference different MS Corely, systemdll, things like this. And I mean, as the types are usually in the same same namespace, then I mean that it should compile quite fine. I mean, this approach has one advantage. It's that you can use even compiler directives to, I mean, if you compile to different platforms, you can slightly change your code. Like for example, if function is not supported on one platform, then you can skip that function, calling that function on the platform. Actually, on the other side, I mean, if you are using this option, then most probably, I mean, it means bad design of your application. I mean, there are other ways how to do it. And I have to share the code. Actually, there are 2 options how to do it. Either linking files in one's in different project files, or using shared projects. Is anyone here who haven't used shared projects? Maybe I just quickly explain or show how it actually works. At first, like linking file, that I mean that might be also quite interesting feature. I will just add here, for example, class 1. I mean just an empty class, and if I want to use it in the same project, in the different project, I can add like existing item. Existing item from console 1. Now if I want to link this class 1, I mean I can add it as a link. And this way, I mean like both project uses the same file. So I mean if I have it opened here, if I add a method, let's say main, I mean it's added also in the other project as well. And I mean this is the way, for example, this, as you can see, I mean this project targets .NET Framework, this one targets .NET Core, and this way actually you can compile like one class for both frameworks. So that's one option. Another option is new project. Yeah, here is the shared project. And shared project actually it does not compile anything. I mean it does not have any actions. It doesn't produce, but then you can, for example, add here. I add here class 2, just an example. And then what I can do is add the reference. Shared project. I add it also, for example, here. Reference, shared project. And basically, what does it mean? I mean, as this project reference is shared project, it means that it includes all the files from shared one. So it means like here I can, for example, use like class 2. Probably it's in different namespace. Yeah, so this is basically how can I share the code and compile it to different platforms. I mean, I will use better or show better approach. Yeah. Yeah. As I said, I mean, currently, I mean, I never use it for this approach. I mean, to really share the code between different platforms. Or very rarely or very little. I mean, what is I think more important is then to use dependency injection, and I mean like share and let's say inject platform dependent code to independent classes. And another option is actually, or better option is to develop the assemblies or to write the assemblies that are platform independent or that can actually target several platforms at once. And how it works? I mean, as I said, the problem is actually, as I said, the assembly format is still the same. The problem is actually like which dependencies to reference. And Then Line Network Microsoft came up with portable class libraries, and it works the way, I mean, in .NET Framework 2, they introduced type forward to attribute. That is attribute that you can attach to the class, and in this attribute you can say that like this type is not here, loaded from different assembly or from different place. Actually, I guess, I mean, they thought that they would like to refactor some types in .NET Framework 1, or when they were updating from .NET Framework 1.0 to 2.0, but I mean, they couldn't because of compatibility, so I mean, they had to introduce this attribute, and I think it's used even inside .NET Framework, because what I noticed, like between different versions of framework, for example, some link queue types, I mean, they were moved from system core DLL to system DLL and so on. So there were some changes. Basically, so how it works, I mean, that they created portable, some portable class library profiles, like for example, MS Curly 2.0.5. And I mean, this DLL, it's just a stuff that, I mean, it does not have any implementation. It contains all the types that are available, like for example, as I mentioned, the GUID types, I don't know, file system and things like this, whatever is available on specific platform. But I mean, this there is no implementation. Then you basically compile your library against this MS Curly 2.5, 2.0. Then when you deploy your application, for example on .NET Framework, then there is this like fake library, so MS Curly, that is, it has all the types, but I mean all the types are empty, and they have just type forwarded attribute that the real implementation is in MS Curly DLL. And for example, then if you load it in Universal Windows platform, then it forwards it to different. Maybe in this case it's the same DLL, but this is basically how it works. And so what Microsoft did, I mean, they defined several profiles, quite a lot of them. I mean, and each profile is like combination, and they created a combination of several or different platforms. For example, if you want to develop a library that can be used in, for example, .NET Framework 4.5 and Windows 8. So then it's that, okay, you want to compile against profile 7, and it's there is basically really like MS Curly DLL that is specifically crafted for profile 7, and it has only the types or only the functions or methods and so on, everything that is on both platforms, so that's 4.5 and Windows 8. And there is, I think, a lot of profiles there. So I can briefly show it. Here is just an example. I mean, like each profile is, for example, if I take this one, is really a set of assemblies. And as I said, I mean, this assembly, I mean, it just contains the empty types with the methods that are available on the platform profile 7. That is basically the .NET Framework, the Windows 8. Yeah, and there is actually quite a lot of profiles. For even here and so on. So this is the way how the portable class library works. Yeah. And another maybe quite important attribute is also target framework attribute. And this way, I mean, you can put it on assembly level, and this is where you can tell like this assembly was compiled against this for this profile. And therefore, I mean, all the references know that, I mean, yeah, I can reference this library because it said, I mean, it was compiled for this little file. So far, yeah, any questions to this? Okay, so portable class library, and the next thing after portable class library is .NET Standard. .NET Standard actually is technologically exactly the same thing as portable class library. I mean, it basically is the same. I mean, it uses the type forwarded tool. I mean, you compile against some abstract or some stub library and so on. The difference is, I mean, is the approach or number of standards. I mean, the problem is that portable class libraries, I mean, the approach was that for each combinations of platforms, they needed to create a separate profile. And I mean, of course, I mean, as the new, and it was not only the platform, but also the version, because the different version has also different API.